Divergence of a vector. The divergence operation is possible for only vector quantity, not a scalar quantity. Okay? When we operate del on scalar, it is a gradient. When we operate del with dot product, scalar product, or on any vector quantity, that operation is on divergence. The divergence dot is important between the del and any vector quantity. So when del is scalarly operated on vector d bar, it is called as the divergence operation. Now, definition, how it is defined. Now, divergence of a bar, it is written like this, del dot a bar written like this. So, how to define the divergence of a bar at a given point P for a specific point? What is the divergence? Is the outward flux per unit volume, right? Outward flux per unit volume as the volume shrinks about P. Now, for this divergence concept, you must know what is the electric flux, how flux lines are originating from a charge, right? So, you know positive charge and negative charge. Positive charge means what? Simple like this. This is the positive charge. So, flux lines are originating from positive charge and it always ends on negative charge. That is the properties of the charge. So, here that means flux. That flux lines means what? This lines, that is the electric flux lines from one charge to another charge. That is known as the flux, electric flux. So the divergence of A bar for any point P. So for that specific point P is the outward flux per unit volume. For that specific volume, we are measuring in terms of area, right? Now here in terms of volume, as the volume shrinks about P, right? Now as per the definition here, this term is referred as the flux for any vector through any vector quantity. So it is a bar dot ds bar. Through this area, vector is this closed surface, right? So whatever the net outflow of the flux per unit volume, this is the delta V per unit volume as volume shrinks to P और जीरो, मतलब वो पॉइंट तक वो श्रिंक होता है. सपोज एक बलून का एग्जांपल लेती हूँ, वेरी सिंपल कंसेप्ट. एक बलून लिया आप लोगों ने, ठीक है. सो बलून को मैंने पिन मारा, तो सपोज वो पॉइंट बोलो आप, वो पॉइंट पी, ठीक है, एक पॉइंट पे. तो क्या होगा, जो बलून में जो एयर है वो कंप्लीटली आउटवर्ड, दैट इज द एयर एक्ट्स एज अ आउटवर्ड फ्लक्स, ठीक है. सारा फ्लक्स निकल जाएगा, दैट इज द एयर, ठीक है. और बलून श्रिंक हो जाएगा टू द पॉइंट पी, मतलब एक पॉइंट पे वो श्रिंक हो जाएगा. गेटिंग माई पॉइंट? तो दैट इज द एग्जाम्पल ऑफ द डाइवर्जेंस, ठीक है. आउटवर्ड फ्लक्स पर यूनिट वॉल्यूम, दिस इज द सिंपल डेफिनेशन, आउटवर्ड फ्लक्स पर यूनिट वॉल्यूम. तो इसको थोड़ा सा जाना पड़ता है हमें इन टर्म्स ऑफ इलेक्ट्रोमैग्नेटिक लैंग्वेज, राइट. The divergence of any given point P, outward flux per unit volume as the volume shrinks about that point P. So that's why in the definition it is written as the limit delta V tends to zero. That means balloon like volume. That volume shrinks to zero when the outward flux, that is the when flux goes completely. So this is the simple definition. So delta V is the volume enclosed by the closed surfaces in which P is located. Now there are the three types of divergences: positive divergence, negative divergence, and the zero divergence. Now what happens in this case? Positive divergence means for vector a bar at this point, vector diverges or spreads out. ठीक है, the electric flux spreads out, that is known as the positive divergence. Okay, this is the property of the charge, positive charge. Always the electric flux lines originate, that is going outward from that positive charge. That is known as vector diverges or spreads, and also known as the source point. Obviously इससे हमें कुछ तो output मिल रहा है, so it acts as a source point. Now the negative divergence, that is the vector converges. Converges means it is the sink point. ठीक है, so यहाँ पे सारे flux lines converge हो गए, sink हो गए, the and the name is the negative divergence. And the third one is the zero divergence. Zero divergence means from this point P or this vector area, complete that flux lines are incoming and outgoing. No any source or acts as a sink point, that is the zero divergence. So if divergence of the vector field is zero, the field is said to be solenoidal field. Remember, this is the one of the get question, simple MCQ type. If the divergence of the vector field is zero, the field is said to be solenoidal field. And having the some value for the divergence, it is a non-solenoidal field, including positive or negative divergence. Okay, now there are some examples here. So divergence of D bar, can you imagine कौन से एग्जाम्पल हो सकते हैं for positive divergence? Now take, suppose a valve of an infinite boiler is open, there is a net outflow of steam, right? From any boiler, net outflow of steam like a outflow of flux, that is the positive divergence. From a charged body, there is a continuous outflow of flux, sun rays coming out continuously from the sun, right? That is the example of the positive divergence. Now, in case of negative divergence means what? Vector converges, right? That means sink point. So, vacuum tube, right? Infinite vacuum tube is broken. Inflow of air, right? That is the example of negative divergence. That is the inflow of air. So, now what are the formulas for this divergence of A bar? Now in this, to find the formulas of the divergence of A bar, when del is there and divergence is there, suppose A bar is equal to AX cap plus AY cap and AZ cap. This is the vector A bar. What is the del? Del is dabba by dabba x, AX cap plus dabba by dabba y, AY cap and plus dabba by dabba z, AZ cap. This is the del. Now when we operate del dot A bar, okay, del dot A bar. So obviously AX cap dot AX cap, it is always 1. So del dot A bar dabba by dabba x, ये वाला, और ये बचा AX, तो यहां पे आएगा ओनली मैग्नीट्यूड. ये वाला AX, ये यूनिट वेक्टर AX और डेल का यूनिट वेक्टर AX, ये दोनों जब डॉट प्रोडक्ट हो गए तो ये दोनों का 1 होगा. So it cancels. Then dabba by dabba x and AX, मतलब dabba of dabba x of ax. Ax means magnitude of vector a bar along x coordinate, x axis. This ay plus dabba by dabba y, ay, and plus third one dabba by dabba z, ये वाला dabba by dabba z, az. This is the divergence del dot a bar formula. Now, as per the result, del dot a bar, it is always a scalar quantity. Del dot a bar, output of del dot a bar is a scalar quantity because unit vector dot product vanishes. One hota hai wo. So there is no any unit vector to represent the vector. That's why it is a scalar quantity. Now same case, these formulas are already given to you, right? So these are the divergence of a bar in Cartesian coordinate, then it is cylindrical coordinate, then it is spherical coordinate. So this is the three formulas to calculate divergence of a bar according to coordinate system.